systematic and just tool meta-analysis. And today I'm gonna talk about errors. One of the most important and the hardest topic in epidemiology. And I have to introduce you to a summary or an introduction about errors because, for example, in our course in PhD of epidemiology, we have, I think, 50 sessions about errors. 15 sessions about errors, and it's very important because if we don't have any errors in a study, it's very easy to do or conduct a study because the most important duty of an epidemiologist is to handle or delete error during a study. Okay, today I'm gonna review the concept of random error, and after that I review the concept of bias, and finally I'm gonna tell you about confounding. So we have three types of error in epidemiology: random error, bias, and confound. And at your final exam, I give you some question, multiple choice question about errors, and I try to send you some, for example, example questions through WhatsApp group. Please answer this question and send me through WhatsApp or email. Please email. Okay. I think we will have a presentation until 12:30. Yes. Yes. After that, we have a break. What is random error? What is random?
Irregular.
Not specific.
Yes. It's random. It means by chance.
By chance.
Yes. And in epidemiology, we have three components or three types of error. And first of all, it's chance. After that, or the second kind of error is systematic. And another type of error is confounding. Chance error, or statistical error or random error is an inherent part of all measurement. For example, hypertension, weight, height, and etc. is an inherent part of any measurement. And the most important characteristic of this type of error is unpredictable and uncontrollable. And for example, some researchers want to estimate the prevalence of obesity, and they use, for example, a scale. In Persian, it's tarazu, for example. And this scale have random error because sometimes it shows, for example, lower weight, and after that, or in the next step, it shows higher weight. Yes? Okay, chance error refers to the variability in measurements or observation that occur due to chance. It's an inherent part of any scientific study, and when we don't have any chance, it means reliability. In other words, no chance equal reliability. I think I'll give you, for example, a question about reliability and validity for final exam. what is the meaning of reliability, and what is the meaning of what does it mean, for example, validity. And in the following, I'll tell you about validity. But no chance error means reliability or repeatability.
So is it possible in field data collection there is reliability?
Yes, I'll tell you in the following. Okay, in epidemiological study, random variation has many components or has many sources, and the most important major or main reason of measurement error or random error is sampling. It's sampling. For example, when you want to estimate the prevalence of depression in Kish Island, for example, sampling, for example, what is total population of Kish Island? How many people?
50,000.
50,000. 50,000. If I include all people in Kish in my study, random variation or random error cannot occur because I include all people in Kish Island. But when I sample, for example, a subset of population, for example, 10,000 people, random error can be occur because the most reason or main reason of sampling error or random error is sampling.
Can you explain it again?
When I include a subset of population in our in my study, random error can be occurred. But
How?
I explain in the following. Okay. For example, let's imagine that this is a distribution of, for example, height in the population, blue or black curve. Black curve shows the distribution of height in the Iranian population, for example. If sometimes we overestimate and sometimes underestimate, for example, height when we measure it due to chance. We have random error and the measurement might end up looking like this. For example, as you may infer, this is a problem because it leads to imprecision, for example. And but with a large enough sample, we can be quite confident that error cancel out. Yes? So, blue curve shows the distribution of, for example, weight or height with random error, but black curve shows the distribution of weight or height with no random error. With random error, without random error. Yes? Imagine we want to measure the weight of a...
The last slide, what is frequency?
What is frequency?
Yes.
Frequency, it's a statistical terminology, and I think you don't have any biostatistic course, yes? It's a distribution, and it means how, for example, variable distribute among a people. For example, in this class, people have a lot of or different weight, and if I graph your weight or height, I can plot a curve, and it shows us the distribution of, for example, weight or height. It's a biostatistic terminology. It's a very important slide because based in this slide you can differentiate between random error and no random error. For example, we want to measure the weight of a 70 kg person, a participant with a weight of 70 kg, and I want to measure this people, weight of these people 5 times and with 3 different scales. Okay? The first scale has neither random error nor bias. Okay?
Yes, sir.
Because it shows real value or true value and true trust every time. Okay? Scale 1 is reliable and valid. Scale 1 is reliable and valid. But in scale 2, as you see, when there are random error, it means when you measure the same object repeatedly, you will have values higher or lower than true value. Okay, sometimes it's higher and sometimes it's lower. Okay. When taking an average or mean is biostatistic terminology, unfortunately. Huh? When we take an average or mean of this value, the average value or mean value will be closer to the real value. Yes? Because they cancel out each other. Okay? It's a random error. It's a random error because it's unpredictable or undirected, without direction. Yes? If the same participant steps on the second scale, for example, 5 times, a slightly different weight measurement may be obtained due to inherent fluctuation in the scale's accuracy. Scale's accuracy. For instance, if a participant true weight is, for example, 70 kg, a scale might display measurement, for example, of 69, 68, 71, 70, and 72 in 5 consecutive, for example, measurements. This small variation or random error that can occur due to factors, for example, like scale calibration, because this scale have a bad calibration. Okay. Since the random error is unpredictable or undirected, tends to cancel out over repeated measurement. So the mean is 70. Okay. When you calculate mean, it shows, for example, there is no difference between average and true value. And one of the most, as I said, one of the most important factors that affect on random error is sample size. When you calculate a suitable or enough sample size for your study, you shouldn't worry about, for example, random error. As I said, when you want to estimate a measure like prevalence of diabetes or incidence of depression in a city, and you include all people and at that city, you shouldn't worry about, for example, random error, because it's a census. Do you mean census?
Yes.
Yes. It means in Persian, sarshomari. Yes. It's sarshomari. Okay. I'll tell you about third scale in the next slide, because it's bias, and I'll tell you about bias. Okay. this slide is very, very important. Today's slide, because it's very important for you to know what are types of random error in biostatistics. Please imagine that you want to assess the efficacy of a drug, or you want to assess or compare the efficacy of two different drugs. For example, there are many types of drug for treatment of COVID-19. For example, Caletrol, Remdesivir, and etc. And I want to compare the efficacy of these drugs. For example, drug A and drug B. In this situation, I face with 4 scenarios. Please read this scenario, and after that I'll explain about this scenario. Please study or read in this 4 scenario. Scenario 1, there is no difference in reality, and we find no difference. 2, there is no difference in reality, and we find difference. 3 scenario, there is difference in reality, and we find difference. And there is difference in reality, and we found no difference. Which of these are correct, and which of these are incorrect?
3 is suitable.
All of them are correct.
Yeah, 1 also.
1,
3.
1 and 3 is true, are true or correct, and 2 and 4.
No correct.
Okay.
What's it?
You should learn it this 4 scenario, because in epidemiology and biostatistics we gave some terminology to this scenario. Okay, we gave type 1 and type 2 to this incorrect scenario. Type 1 error and type 2 error. Please look at this slide. Type 1 error is when there is no difference between the therapies, for example, drug A and drug B, but on the basis or based on the sample of subject included in our study, in your study, we incorrectly conclude that they are different. It's type
2.
1, type 1 error.
Type 1, but the point was 2.
Yes. And type 2 is there really is a difference between 2 therapies, but based on the sample included in your study, we incorrectly conclude that there is no difference. If it will be a question for final exam. What is type 1 error and what is type 2 error? Based on this table. Okay?
Sir, can you explain it again? Yes.
Okay.
No,
I got it.
No, sir. Can you explain it again? Can you explain it again?
When we want to compare the efficacy of 2 drugs in 2 scenarios, we can, for example, we can do work incorrectly, or we can draw a conclusion incorrectly in 2 scenarios. Scenario 1, when there is no difference between the therapies, but
We find
based on your sample or your study, you conclude there is a difference between the efficacy of these 2 drugs. Okay, we call it type 1 error. Okay, and another type of random error is type 2. There really is a difference between two tropies, but based on your, for example, your study, you cannot find any difference between two drugs. In reality, there is a difference, but in your sample, you cannot find any difference between two drugs. Okay? It's type 2 error. In biostatistics, it's so hard. In biostatistics, the probability in Persian it's ihtimal, probably, ihtimal. For example, when I want to calculate the probability of being women in class, for calculating this probability, I should divide the number of female to total number. Yes. The probability that we will make a type 1 error is called alpha. What is alpha? The probability of type 1 error. It will be your question in final exam. I'm telling you their question. And the probability of type 2 error is beta. Okay? And what is p-value?
Sir, mean value of
Mean value of
alpha.
mean value of alpha and
No.
possibility.
P-value is alpha, but after your study. For example, before study, you consider a amount of probability or amount of error, and they called it, for example, alpha. After
Study.
or at the end of your study,
Conclusion.
the software, for example, SPSS, Stata. Do you know SPSS and Stata?
Can I say it's like that? For example, when we are calculating something, after calculation we add 0.5
Yes.
to correct the dead random error.
Yes. Yes. It shows the amount of or how much, for example, your result is because of chance. P-value shows us the amount of being chance, for example, in your study. Okay? And for example, when p-value is less than
0.5.
0.05, it shows, for example, tropy A differs from tropy B on the basis of your sum. Okay?
No, sir, this one. Repeat this.
Okay. What is type 1 error?
Type 1, that there is a difference, but we find no difference.
Yes.
It is called
And the
alpha.
probability of this type of error is alpha.
Yes.
Okay.
Yeah.
The software calculate the amount of the value of alpha after your study and called it
P.
a p-value. P-value, for example, when p-value is less than 0.05, it shows, for example, there is a difference between two tropes.
How much error we have found? How much error we have?
Yes, yes.
Sir, this p-value is due to scale. The scale due to calibration.
I don't
Is there
understand.
a difference between actual
Language.
value and
Please
error?
translate.
Sir, actually, I am unable to understand first what is alpha.
Alpha is the probability of
Type
type
1.
of study.
Type 1
For
is
example,
Like how-
if you minutes ago I calculated the probability of being women in class. Yes, in designing of a study, you should consider, for example, a probability for occurring type 1 error. And it's as a rule, as a usual rule, biostatistician or epidemiologist consider, for example, 0.05 for alpha before a study, and after a study, the software calculate the amount of alpha and call it p-value.
And for 0 probability है एक्सप्रेशन गलती की है, ठीक है? अगर 0 probability
Yes.
Yes. Sir, A is the chances of error. Then B is after result we have the chances of error.
Please write your question.
He's saying alpha refers to chance, error chance, chance of the error, probability of the error.
Yes.
And what we say is after we get result, we refers to the actual.
Yes. The amount of actual chance.
That's what it is.
Actual error here.
Probability of taking a type 2 error is power. Please look at this slide and please take a photo from this slide. Including the treatment differ when in reality they do not. Okay? Beta is probability of making a type 2 error or probability of concluding that the treatments, for example, drug A and drug B, do not differ when in reality they do differ. What is power? Power, yet 1 minus probability of making a type 2 error. It doesn't matter. It's a most important component for calculating a sample size for your thesis. For example, when you want to write a proposal for a university, one of the most steps in writing a proposal is calculating sample size, enough sample size. And there are many formula for a statistical formula for calculating sample size, and one of the most component of this formula is power. It doesn't matter for this session. I want to know there is a terminology called beta. It doesn't matter. Yes, but it's important to know one of the most important component of sample size calculation is power. There are many approaches for minimizing chance error. For minimizing chance error, there is a lot of approaches. But most important approaches is calculating enough sample size and reporting of p-value and confidence interval. It can be, chance error can be estimated and expressed quantitatively using p-value and confidence interval. It cannot eliminate it, but it can be decreased by using, for example, large sample size, as you see, and when you, for example, include the total population in the studies, its census, we don't have considerable random error because sample size is very high. And when we have a large sample size, we don't have any chance error. For example, I think there are 10,000 students in Tehran University of Medical Sciences, and when we want to estimate, for example, the prevalence of physical inactivity, because of including all students in our study, we don't have any chance.
Chances.
But when we want to estimate the prevalence of physical inactivity based on a sample, for example, 1,000 students or 2,000 students, our estimation or my estimation, for example, can be because of chance error, for example. And p-value and confidence interval are two common approach for showing how much our estimation or our result is because of chance error. P-value and confidence interval. In the context of, for example, random error, p-value helps us to express or assess whether the observed effect or association in the data is likely due to random error or chance error, or if it represents, for example, true association. Yes, a small p-value, typically below a pre-specified threshold, like for example 0.5, suggests that observed effect is unlikely to be due to random error. When p-value is less than 0.05, okay? And p-value is a probability, and a probability is a range from 0 to 1. Yes? Deal between among biostatisticians. For example, most biostatisticians prefer to determine or specify a threshold at 0.05. But in basic science, for example, in basic science, the researcher prefer to decrease the threshold of chance error because they do they work with high quality equipment, for example, or devices, and they expect to occur low amount of chance in their study. Yes. So the most important factor for determining a threshold is p-value threshold is based on, for example, your field.
Precision of instrument. Like the precision of instrument.
Yes. Yes. Okay. And the confidence interval is often interpreted as indicating a range within which we can be, for example, 95% certain that the true effect is like it doesn't matter. For example, it's a pure biostatistical issue or topic. So in this class, I expect to learn the definition of chance error for random error, and the types of random error, and definition of types of random error, and approach for management or handling of chance error. And they were calculating enough sample size and p-value and confidence interval. P-value and confidence interval are two biostatistical approach for showing the amount of chance in your or in their results. Okay. After chance or random error, I'm gonna tell you about bias or systematic error. Systematic error or bias is any systematic error or misleading work in design, conduct, or analysis of study that result in a mistaken step. For example, when you want to estimate the association between alcohol consumption and cancer, bias can create overestimate or underestimate the amount of the strength of association. For example, relative risk or odds ratio. It depends on your design, for example. And no systematic error means validity. When you don't have any systematic error, your work is valid.
Valid.
Your study is valid. It's another definition of bias, and in this slide you can compare chance error and systematic. Please look at this slide. As you see, in three scenarios, for example, the researcher used a scale that consistently overestimate the participants' weight by a certain amount. For example, 1 kilogram more than reality. Yes? And this means that the scale readings are consistently higher than the true weight of a participant. In this case, the study result would be biased. Why?
It is a systemic error
Yes.
because of
Because
the
it
scale.
systematically overestimate participants' weight. Yes? For example, if the true weight is 70 kg, the scale may consistently display, for example, a weight of 71, and this bias can arise due to various factors, for example, calibration issue and etc. And when you calculate the mean of weight, it's overestimate. Yes, it's higher than true value. Systematically, we faced overestimation. And unfortunately, because it's a systematic error or bias, you cannot reduce it by increasing the sample size, because it systematically overestimates the weight. For example, if I measure the weight of a participant, for example, 10 times, and after that I calculate the mean or average of weight, again the average is 71, because it systematically overestimates the weight. Yes?
Sir, in systematic error, the value is always higher than the normal, the original value.
No,
No, maybe.
sometimes it's higher, sometimes it's lower. Yes.
So
It
it's-
depends on the scale calibration.
Is it a technical issue of the devices?
In the following, I'll give you some example. Bias, your systematic error can happen in selection of participants in your study or in data collection process. And when systematic error occur in method of selection participant, we call it selection bias. And when we have a systematic error in data collection, we called it information.
Information.
Okay, I think that's enough for this section, and